Hello, this is Dr. Sung Shu of Keysight Technologies. In this short video, we'll introduce some of the basic steps of imaging processing using the Keysight technology Pico Image. In the software, we first start with a new document. Here, pay attention that document is a file where we put all the processing and imaging together. So here we've got a file and new document. In the headline, we could choose the tag that says studyable. Here we use the name studyable to describe an AFM file. Let's load a studyable. Now this is they call it studyable, and this studyable file has 1, 2, 3, 4 pages. The first page is topography, and second and third are amplitude and phase, and we're going to only introduce the processing of topography. So step number 1 is extract the first page of topography so we can do some processing on it. Let's go to operators and then extract area, extract layers. Choose the layer you want to extract. In this case, it's a topography image. Click OK. And then we have the single page topography image. Now, the first step of an AFM image is to remove any tilt and line noise from the image itself. Typically, we would use something simple as a level. So click here, go to operators, level, and we choose a 3-point level. We choose 3 points to define a plane and click OK. The software will generate an image that's correct through the 3 points. Now notice that still have line by line shifts in this image. So we're going to go to the next level of flattening. We call it a line flattening. Again, click on the image, go to the studyable, go to operators, and level line by line. Click that. It opens a page here. Here we choose a second order polymeral degree to correct any bowings, and then we choose the entire area, and then here we choose automatic structure exclusion. This automatic structure exclusion is very important. This will help us to remove any artifact caused by high features. In this case, we choose the features above the ground, which are those DNA dots and protein dots. And then we can choose either strong exclusion, normal, or weak. In this case, these features are relatively small, so we choose a weak exclusion. Click OK. It generates the next page of topography image. In this image, the line by line noise has been removed. And let's go to the next step to adjust the color. Go to the palette, click on the palette menu, and click Edit Palette. And go to the color scale. In pull down menu, choose Display Histogram. Now, by pulling these little arrows up and down, you could change the display range of the color palette in order to give you a much better image and contrast. When you finish with that, again, you can go back to the color scale and remove the histogram. And you can also remove the edit. The next step, let's do some filtering to remove some of the noises. Again, click on the image, go to the operators, and in the operators, we're going to choose spatial filter. And here, you could choose 3 different types: the Gaussian filter, the splinter filter, a robust Gaussian filter, and Gaussian filter is the mostly used. And then here we choose a cutoff frequency. Basically, you want to choose how big is the feature is considered to be feature and how small is considered to be noise. When you choose a large number, the image will appear to be very smooth, but you can also lose information. When you choose a distance which is too small, then you're not sufficiently filter out the noise. Here we choose 0.008 micron, which is 8 nanometers. Click OK. This calculation generates two images. One is the low pass and one is high pass. And we can choose to keep one of the two. Here we want to delete the high pass, which we think is the noise, and only keep the low pass. Again, we could choose to change the color palette, make it appear to be a better contrast. Now, in order for you to do some measurement, we could also generate a profile. Again, click on the image, go to the operators, and then we choose extract profile. And here you can choose this line, either west-east, north-south, or any arbitrary numbers, arbitrary points. 1 and 2. Make sure you align across any features you're interested to measure. Click OK, and then you generate a cursor profile. And from the profile, you can easily measure the height of certain features. The next, what I show you is how to generate a three-dimensional image. Again, click on the image. This time, we choose the studies. Click on the studies, and then here we choose a 3D view. Now a 3D view is generated, and again we could change the color palette and according to histogram, and make the image appear to have a better contrast. We're also using the mouse to change the tilt angle and the location of the 3D view. And let's remove the histogram and the color scale edit. And then when you're ready, you could extract this image into a PDF file and save it so you can use it later. Before we finish, let me show you also different kind of color palettes. Here you can choose different type of color. For example, this is an interesting color. Or we could choose this thermal color. Once you are satisfied by the image you generate on the screen, including the color, the tilt angle, the scale, either 2D or 3D, you could output the image into JPEG files or any image files that you can open and use in your presentation and papers by right-click on the image and then choose Export Image. And then here you could choose JPEG, GIF, TIF, BMP, or EMF. Here I will choose JPEG. Give a file name, example, and click Save. And this image will be saved in a format you can cut paste into your paper or presentation. And these are the simple steps of how you turn your AFM data into usable images so you can use them in your presentations and papers.